Hi, everyone. I'm Alex, and I lead OpenAI Academy. I'm so glad you could join us today for this session with our community partners at DeepStation. At OpenAI Academy, our mission is simple: to help people everywhere learn how to use AI in ways that improve their work and their communities. From small businesses to nonprofits and large enterprises, we create learning resources and host events like this one that aim to make AI accessible to all. A big part of how we do that is through collaborations with people already doing the work of educating their communities about AI. DeepStation was one of our very first community partners. We actually met them almost a year ago before we even launched OpenAI Academy. And we saw firsthand the incredible work they were doing to help people in the Miami area and beyond begin building AI-powered solutions. So I'm really thrilled you're here with us today. I'm really excited to have Grant, who's the founder and CEO of DeepStation. And we'll hand over to him now to tell you more about DeepStation and then kick off today's program. So thank you all, and check out more events and resources on the OpenAI Academy website. All right, over to you, Grant.
Thank you so much, Alex. And hi, everyone, and welcome back to another amazing session of the OpenAI Academy. I'm Grant, your host from DeepStation. We are a community launch partner of the OpenAI Academy, together with Miami-Dade College. Miami-Dade College is the largest student body in the United States, and DeepStation would not be here today without our close partner. Thank you, Pedro Santos Acosta, for introducing us to Alex Noir and the OpenAI team. I have had the great pleasure of getting to know Alex over the last year, and his ability to unite leaders globally from the United States to South Korea have been remarkable. I certainly recommend watching his inspiring AI for Economic Opportunity Demo Day with GitLab Foundation and OpenAI Academy. I also want to give a shout out to two incredible community builders, Jane Kim and Natalie Cohen from OpenAI. Now you might be asking, what is DeepStation? We're on a mission to accelerate AI education and innovation through our 3,000 plus AI powered community, bringing together engineers, professionals, and enthusiasts so we can all stay ahead of the AI wave. We are currently funded by the Department of Commerce, the United States Economic Development Administration, Kaufman Rawson, and Miami TechWorks for economic development across South Florida, and soon the world. Enough about us. I'm excited to introduce the real star today, Mash Saheed. He will be sharing about a topic that seems to be getting a lot of attention on scaling enterprise AI through systems thinking. His perspective will be more focused on the business side and less on the developer side. This is well suited for folks in enterprise, but also startups who are looking to grow exponentially through the union of human and AI. Mash is a management consultant who's been, as he puts it, around the block. He did a lot of work with JP Morgan, KPMG for global AI strategy, IBM as a leader focused on energy and utility companies, Home Depot, clients like Amgen in biotech, and now helping for the leadership at a major automaker. He's a very good friend of mine, and I first met him at one of our community events around a year ago. Not long ago, I had dinner with him and his wonderful family. He told me what he was working on, and I felt it was worth discussing here. We always enjoyed talking about AI and the intersection of business, and I'm excited to learn from him today with you. Nash, take it away.
All right, Grant, thank you so much for those very kind words. Hi, everybody. Without any further ado, if I can get started, if you can all see my slides. So this is what we're going to be talking about today. As Grant mentioned, how do you scale generative AI, LLMs, and all of the emerging really cool stuff that's coming around almost every single week, and to use that to build your organization. There are so many stories out there, aspirations certainly of solopreneurs and so on. But at the same time, there's certain realities. So we're going to cover all of that around some principles that I believe are foundational when you're starting to think about how do you adopt and infuse and grow business using all of the incredible and soon to come for sure the AI innovations down the pipeline. So let's get started right away. Now, I'm going to answer first question. If you want the slides, they're already out there. Everything I'm going to cover, the slides and a code notebook that if we have time, we'll cover. But I'll really try to get through all the slides. Hopefully it's not too dense, but cover through all of that, and then we'll do some Q&A and so on. So just use this QR code, and let's get right to it. I may not be able to see everybody, but let's move things around a little bit there, just so I can see. All right, so let's get started. As I was telling you, there's a lot of reality things to consider. About 3 months ago in July, MIT researchers from NANDA, they released this paper, brilliant paper. Just Google this, get hold of this, very easy to just absorb quickly research paper that covered a number of different things. So while we're witnessing this greatest expansion in human history, yet, as they find, 95% of AI initiatives, proof of concepts and so on, fail to achieve that rapid revenue acceleration that was promised. So we want to get to exactly why that is. So let me outline some of the excellent points that were mentioned in this MIT research study, and what they mentioned really as being broken. First, there was, as I said, 95% of those initiatives failed to deliver zero profit and loss impact. And yet also they found that a lot of the tools that the AI tools that they were using, they didn't retain feedback, they didn't adapt to context, and most importantly, they just weren't able to integrate to the companies and the entities' process workflows. It gets even more interesting. The funding, seems obvious, but funding really was put more on the front-facing functions rather than the back end, where there was a lot more ROI. And, honestly, as an operator, this is hard to do from my perspective, because frontline businesses, they perform better. It performs better. Like AI adoption would perform better if frontline businesses have the ownership than if it was just up to IT or tech alone. Finally, there was also this build bias, as the researchers called it. Now, what they showed, actual numbers, external partnerships were successful, when you looked at the success stories, 2/3 of the time, versus internal builds were only successful about 1/3 of the time. And this to me is counterintuitive, because of course you want the domain experts internally to build it versus outsiders coming in, but those are the data. So it gets a little more interesting. I'll see if I can show you, like if you go to the study itself, it provides some really good high-level insights that you can apply almost immediately. So let's get right back. This paradox isn't really technological, as you can see. It's organizational. This is, after all, strategy and operations. So I believe that most companies are just applying linear thinking to what is, with AI, exponential technology. And that's what I want to show you today. This is how companies like, say, Netflix uses talent density philosophy, or Coinbase uses a first principles approach through systems thinking to create a strategy for AI-powered enterprise transformation that would apply both to startups, small startups, as well as within large corporations. Note, this success requires organizational design that's going to compound learning. If that's not clear, it will be in just a moment. So when you break it all down, take 100%, that pool of 100% of the companies that were studied in the MIT paper. Most companies, most startups even, are stuck in level 1. They're building features that ultimately other competitors or players will either just copy or acquire or acqui-hire, as it's been happening in the Valley lately. That's the large part. That's 70% of the companies, just roughly speaking. And then there are companies that do a little better. These are the level 2 companies that have optimized their workforce planning. They get efficiency gains and so on. These are, they're set up right, but they haven't reached that top 25% yet, or top 5%. This is up to the 95. The winners, however, that very top ideal 95%, those are Netflix, Coinbase, emerging unicorns such as Lovable and Plod. Plod's a new one that's getting a lot of recognition lately. They operate at the levels 3 and 4. They don't just use AI, they've restructured their organizations around AI's capabilities. It's not just about building better tools. It's about building better organizations. And this is really what I want to show you. I want to show you what, when you look beyond the tools, software, and instead focus on building a learning organization. Let's focus on that top 1%, the bottom. One where you can have continuous improvement and you compound intelligence that's self-reinforcing when infused into and within the organization. That's the sweet spot. So what I want to show you. I'll show you a pattern that separates that top 5%, getting up to that top 1% of the ideal learning organization. So without further ado, let's get right to it. Why me? As Grant put it, I've been around the block. I know even this bio slide gets a little too dense, but I've been a management consultant and an AI engineer with real enterprise deployments and startup experience under my belt, working on the pure strategy side to help develop companies, things that you will have heard of and seen, to working as a data scientist, a machine learning engineer, where I have been truly lucky to have had some incredible experiences, fortunate enough to have worked with great companies and clients. So I'm bringing that, and it's that experience that's really going here, plus a lot of information, publicly available research and so on, just putting it and synthesizing it together for you. So in a couple of sections, we'll do this in 2 sections. In the first section, I'm going to use and cover 4 principles. These are the ones I think everybody noted in the abstract to this talk and are really interested in. We're going to talk about first principles, and we'll go into systems thinking, which I suspect that squarely is what you're keenly interested in. And we're going to look at principles of talent density and AI's multiplier effect. While discussing some of these principles, I'm going to share a novel idea before we get to section 2 on how you can apply these 4 principles into an AI-powered framework. So if that sounds good, let's proceed to transform business workflows using first principles of systems thinking. So before we dive into systems thinking, let's establish a foundation. What's first principles? A lot of people may already know this, and just, let's start simple. Most businesses operate, by analog, by analogy. Just, this is how banks have always worked. So if you want to build a bigger bank, here's how you do it, step by step, and so on. On the other end, if you take first principles, this is what Brian Armstrong, the CEO, founder of Coinbase, he approached it differently. He asked a different question. What fundamental problem do banks solve? That answer was establishing truth in transactions. Establishing trust in transactions. But that trust doesn't require having all the buildings and bureaucracy and so on. It required verification. So starting from a first principles mindset, Coinbase built a cryptographic verification, not institutional infrastructure. That same principle applies to AI transformation. Everyone assumes scaling just means hiring more people because that's how it's always been done. But when you break it down to first principles, what you really need is accurate, timely responses to customer needs. And once you see that solution, it becomes clear. A small team orchestrating AI can deliver better outcomes than a large team without access to AI. So a little bit more on first principles and that mindset. It isn't about ignoring experience, mind you. It's distinguishing between fundamental truths and inherited assumptions. So as we explore systems thinking in my next few slides, we'll repeatedly return to first principles. What's the problem we're actually trying to solve? What's fundamentally required versus what's just tradition? For those who are familiar with this concept, you'll see, systems thinking really amplifies first principles by revealing those hidden assumptions and complex org structures. But for those new to it, think of this as intellectual archaeology. You want to dig past layers of how we've always done it to find that bedrock truth underneath. So you look at this, the 6 dimensions here. A review just sort of, all of this indicates there are artificial boundaries that exist between historical specialization, which really may not be absolutely necessary. So when you start to design, say, service tiers from first principles thinking, you should really look at resolution approaches for scaling, not organizational structures and barriers. We'll try to simplify and get through more of that. So now systems thinking. So this is put in its fewest number of words, holistic innovation for sustainable impact. Well, what is that? This is, systems thinking really was a concept that was popularized by Peter Senge in his classic book, The Fifth Discipline, 1990. He teaches at MIT. Please watch his videos on YouTube. Wonderful, warm instructor, professor. I've had friends who had the opportunity to study under him, and that was the highlight of, one of the highlights of their education. So systems thinking really recognizes and embraces complexity. Instead of isolating like one aspect, it considers the entire network of interactions. Solutions that aim to make the whole system much more resilient and avoid unintended side effects that would come from other modes of innovation. What are those? Other modes of innovation being, say, breakthrough thinking. This is what tech entrepreneurs just, move fast and break things. They ignore existing norms and rules to achieve the radical product improvements. And this is where you can begin to leapfrog to solutions and get to huge rewards, but it's also going to cause some collateral damage in complex workflows. So that, you have to think about that one. The other, design thinking, which is user-centered innovation that IDEO had come up with quite a few decades ago. This design thinking really focuses obsessively on end users' needs and experience. So if you zoom in on one strand of the problem, the user, and then you produce highly intuitive products and services for that user, but you're going to ignore the broader system. And when you do that, you're going to create knock-on problems for other stakeholders. System thinking is much slower and much more challenging. You just can't slash and burn your way through it. But systems thinking yields a lot more creative, stable solutions in the long run compared to these other innovation modes. So why would this win? Why would systems thinking and that mindset win when you're doing AI transformation? It was reported even as recently in the September-October issue of Harvard Business Review. There's a great article on systems thinking. Please, just by coincidence was there. Please do get your hands on it if you can. The authors there, they analyzed a whole bunch of companies using systems thinking. And they found that second that systems thinking companies, they achieve 2.5 times higher returns than those traditional innovation modes like breakthrough and design thinking. Now, where linear thinking looked at each step one by one, design thinking, this recognizes that in complex organizations, everything affects everything. Netflix's recommendation engine isn't just a feature, it's a learning system that saved them over $1 billion annually in customer retention by creating those compound improvements that went with their system. So you have things such as the reinforcing the learning loop. You have talent loops, small, high caliber teams that leverage AI tools, which in turn draw even more top tier talent to want to come into your organization. You've got the flywheel going there. And then you have a value loop where your initial success breeds even more success. And as AI begins to deliver value, the adoption grows, yielding more data to enhance even further. And think about Tesla. Tesla's full self-driving model comes from the fact that Tesla vehicles being out on the road have enabled it to have so much more training data that can help them build even smarter AI. So with that, let's move on to the next principle. This is number 3, talent density. And at its core, talent density principle isn't just exceptional talent put in it really is. It's just exceptional talent put in high context environments so that they produce exponentially greater output than just, average folks in very rule-bound systems. The key takeaway here is, in order to get to talent density, you just don't hire better people, but you also have to design an organization around them with HR enablers like minimum bureaucracy, radical transparency, context over control, trust over process. So the example here, Reed Hastings, founder of Netflix, he discovered that with just one exceptional person within the proper context, that person could outperform 10 regular average folks, even if you give those folks all perfect detailed instructions. Now, I recognize comparing Netflix to Disney, as you see here on this table, may not be absolutely fair, but just bear with me. Netflix, as you can see, generates 6.5 times more revenue per employee than Disney. And here's what most people even miss in this. Again, it's not about hiring better people. Netflix redesigned or designed right from the start and redesigned as they went along their entire organization around this assumption of having exceptional talent. No approval chains, no expense policies, just radical transparency. And this pattern is kind of counterintuitive. Winners aren't hiring more people. They're actually hiring fewer people. So you've got examples out there, like Lovable. I mentioned earlier that their number, revenue per employee, is 6.7 million. Compare that with like a typical SaaS, software as a service company, 200,000 per employee. So it's not about working harder. It's a fundamental architectural difference in how the companies are built. So from a strategy standpoint, they're not just using AI to do more of the same things. They're using AI to do things differently. So now imagine for a moment, just for a moment, if you were amplifying that with generative AI. So last principle, the multiplier effect. So what I have here on line number 2, if you can see my mouse analytics, this one, this is in 2003, researchers from Harvard Business School. They studied 758 consultants from Boston Consulting Group, controls and so on. And For some, they gave them ChatGPT version 4, V4, and they found that overall, 38% productivity gains on average. A little bit more on those numbers. The HBS researchers, they found that the BCG consultants worked 25.1% faster. They completed over 12% more tasks on average, having access to GPT-4. And they produced 40% higher quality work than the control group, who did not have access to GPT-4. It's harsh. But those BCG consultants with GPT-4, they struggled to do tasks that were outside of what the large language model could do. So again, that's sort of linear thinking coming in. You want to start to really think a little differently. The real multiplier from having GPT-4 or like having AI comes from a compound effect. So say, for instance, a developer using Copilot isn't just coding faster. They're actually attempting to make more ambitious projects. A financial analyst isn't just building more models, but with the time savings, they're going to go out and try to find patterns that they and other human analysts missed before. So you can see you start with that 14 to 18% individual gain, personal gain. Then by year 3, organizations are going to see 5 to 10 times greater impact, not just from the AI alone, but from how the organization itself learns and adapts. So here's putting it all together. Here's what separates that 5%, top 5% who succeed. And instead of going from this traditional approach of linear growth, let's apply the experience that Netflix discovered with talent density, multiplied by Coinbase's AI leverage, raise it to the power of learning velocity. And then you get this equation. It's a heuristic, not much of an equation, but applies. So talent density, let's break this out. To get to exponential growth, you've got talent density that enables better use of AI among its people. You've got AI leverage that accelerates learning. And then you have velocity that compounds the gains, raises up exponentially. So the result, exponentially, you get that exponential growth that our favorite top 5% who succeed, how they can pull away rapidly from the rest. So this is what we're going to try to implement next. Next section, I'll try to build a framework around this, and then we'll try to get to some code. So we're in the next section. Let's apply all the insights from those 4 principles that we covered and try to put it together into something we can all use. Now, this is based on my personal experience, seeing successes and failures with loads of companies that have been trying to enable and apply generative AI over the last 3.5, almost 4 years or so, and just being a part of more pilots than I can recall counting, both and also working with startups and so on. Pattern just to me seems clear. The winners implement all 3 of the pathways that you see here. They're rather simple, if I may say. These seem so for me. First, architectural simplicity. That's just knowing when not to use AI. Don't agent everything. That's just common sense principle there. Don't agent everything. Keep it simple. Second, productive tensions. And we covered a little bit of this in the earlier principles, but those are where you deliberately maintain conflicts internally within the organization that spur and drive innovation. And finally, learning velocity. That's just having the right systems that improve automatically through reinforcing and balancing systems thinking feedback loops. So let's go into this a little bit. As I mentioned, pathway one, architectural simplicity. The number one mistake that everyone makes, I'm trying to go slowly because I'm sure you all get this, over engineering. So you can look at how, even a typical case study, they will build a multi-agent system, 5 agents, 3,000 lines of code, push it out there, and you run out of money in 6 months because it's just used up all your budget. The right approach, take a tiered approach where you have different, break out the transactions, make sure that you architect the solution in different service level tiers so that they do everything differently. Ultimately, follow the first principles architecture approach, where you recognize that complexity should scale with the value that's delivered. This is where you'll notice how simpler solutions, this approach just handles the majority of needs. So it's this tiered graphic here. This shows you that first principles architecture. And so what you really want is your complexity needs to match value, not our technical ambitions. And much more importantly, simplicity compounds those efficiency and scalability gains. So let's get to the next pathway, productive tensions. These are conflicts we deliberately maintain because they drive innovation. A few examples, 3 examples. Siemens. Siemens had their quality team demanding perfection while their IT team pushed for immediate deployment. So instead of choosing one over the other, Siemens allowed that tension to just maintain itself. And that friction between the quality team and product technology, that forced them to invent an entirely new inspection algorithm that achieved 99.9% accuracy in 10 days. That would not have been possible if either one of those stakeholder groups had won. Netflix, been using that quite a lot, but even Netflix, they have this mantra, freedom versus responsibility tension. So engineers say, nope, give us full autonomy, we'll build it, and so on. Leadership, no, we need aligned outcomes. Just working through that tension that they sort of focused on, rather than just getting rid of the frictions, they got to this framework that they have within the company, context, not control. And it's that part, those frameworks, that part of grounded in Netflix's culture that helps them get to the 5 times faster feature deployment, 73% fewer production issues. One more, Coinbase. So this company sort of had to embody the crypto ethos of what is trustless and permissionless, but regulatory reality. You got to know your customer, you got to have anti-money laundering, and so on. So that, at its core, that led to Coinbase resolving that natural tension that were part of their core business model by crafting an entirely new automated compliance using smart contracts. Pretty clever. They removed that constant need for human eye oversight. Really clever design and implementation, if you can all get into that. It's worth the time. And that result, their platform gets 99.9% compliance rate with 90% fewer compliance staff compared to the legacy financial services firms. So When we code agentic AI methods, this means we're building systems where different agents advocate for different objectives. That's the way to think about it. Netflix's freedom and responsibility isn't just a slogan, it's an engineered tension. The engineers have complete freedom to deploy to production, which is a natural tension with what reliability wants. So their tension just sort of forced them to build even some of the industry's best deployment tools. If any of the technical engineers here would know Chaos Monkey, Spinnaker, all of those innovations that they've open sourced and put out there, those things happen because of that tension zone, not despite it, but because of it. So, final pathway, learning velocity. This is essentially the compound effect that you get from learning, amplified by AI. That just goes back to improving the system. This learning velocity is the speed at which the organization absorbs feedback, adapts, and improves. It's measured just how quickly the teams can iterate, how fast the AI models retrain, how often, based on existing data, RAG solutions, how often insights can be shared across domains. This high learning velocity could, if you're not careful, could also turn mistakes into momentum. So you've got to be really careful there. And to do it right, that learning velocity is basically just how fast your system can improve without the human intervention. And the point here really is that learning velocity compounds like interest. So there is also one hidden danger in AI adoption, and that's this first principles decay. And I really do need to bring this out and highlight this as well as part of this. When you're on this pathway, and everybody begins to use these pre-built solutions, you lose the ability to innovate from fundamentals. Yeah, it's what, without that first principles rigor, where, remember, you're laser focused on just what's needed, without that first principles rigor and innovation, will plateau. It'll be like we weren't doing anything at all. And so there's this line here. This is from an OpenAI research study they did with, I think last year, with the launch of the O1 model. There were two papers. This was the end of paper 2, near the conclusion. So just FYI, you can read it there. We risk creating a generation of researchers who are just comfortable with applying those existing solutions rather than developing new ones. So if you, again, I'm going to bring back Netflix, just because we've been talking about it so much. With a hybrid model that like what Netflix uses, we can balance the velocity with fundamentals and create a system that gets exponentially better over time. So Netflix solved this with a hybrid architecture. Most engineers there use tools for velocity, but then everyone rotates through building core systems. And that sort of preserves that first principles mindset while still maintaining speed. And as their learning velocity compounds, I mean, what has been reported, they get 8% monthly improvement and that compounds in just 2 years. That's another over 6 times advantage, just doing the arithmetic. And that's the difference between like a tool, where a tool just stays the same, and a system which gets better. This is how startup companies build moats. This is how large enterprises transform sustainably. So let's try to build it all together. Remember, we're talking about Peter Senge. Let's integrate all of those pathways and the principles. Keep that in mind. Let's integrate them all. So if you build on talent density and system thinking feedback loops, the ultimate goal is really just you want to get to a strategy for building an AI-driven learning organization, that top 1%. So I'm going to riff on Peter Senge's the concepts in his book, Fifth Discipline. And we talked about it. So to describe an organization that's skilled at creating, acquiring, transferring knowledge, and even modifying its behavior to reflect new knowledge and insights continually. So in this context, right, of scaling enterprise AI, whether that be with a startup with talent dense few people, or some entity within a larger complex corporation or function, let's translate that into architectural process framework here that can be baked into operations. 1 through 5. First, systems thinking. This is where AI reveals the patterns that you can't see. 2, personal mastery. This is where AI provides that personalized development. 3, mental models. This is where AI, machine learning, and so on challenge our bias with data, all of our biases. 4, shared vision. AI helps align all people in the organization, no matter what the size of that organization. Small startup, large organization, large corporation, so on. When all 5 work together with AI amplification, that's when you get that exponential growth and that AI multiplier effect. The stuff that exemplified by Netflix, Coinbase, and those examples we talked about. So, theory without implementation is just philosophy. Apologies to all the philosophy majors who honestly now have senior leadership roles in AI technology, law, government. Anyways, so here's my 4-phase plan for implementing our framework. First, pick one process, map its feedback loops. Identify the natural opposing forces within your organization, those tensions. Next, build the simplest possible solution. Then add just one agent where its complexity can start to demonstrate and produce some value. And you can test it and experiment with it. And then start to introduce productive tensions. So that's where you're going to put it and measure the learning rate. You're going to pit it against competing metrics and objectives. And through all of that, measure the learning velocity. And then you decide if it's working out, and do you want to scale that, or do you want to stop, pivot, try something else? So, Grant, how are we doing on time?
Hi, Mash. Yeah, so right now we are at 45 minutes. So I believe you have, yes. So go, I
Okay.
think you're pretty good.
Okay. All right. So then we'll do a very quick code review because I'm sure there are going to be a lot of questions. The code notebook is on GitHub, where I've produced a healthcare model where I'm using AI systems to do with agents to do everything. Just to be able to highlight what I showed, we want to try to get to these 4 implementation process steps. So if you look through my notebook, didn't want to take Murphy's Law risk of running the entire notebook right in front of you. So a couple of screen grabs and you'll see this already run there. This is one section where you want to find those feedback loops and code the agents that way. This is where you allow the agents even to face those natural opposing forces. For instance, you'll have agents focused on clinical urgency and then agents on cost optimization versus patient engagement agents. So you push them so that benefits agents, all of that, they're constantly trying to optimize and use that to find feedback loops. Next. Don't agent everything.
Yeah.
That healthcare orchestrator, you don't want just automate tasks. You want to create those structured conflicts between clinical quality, cost efficiency, and patient engagement. And that's specific to this healthcare journey solution case that I've built. This is where you want to try to keep agents and so on as needed, and to get to that multi-agent orchestration that ultimately drives continuous improvement. So feel free to use that as template. Next, you want to introduce new tensions as you do this. Sort of hinted at that 2 steps ago. You want to try, because you want to try to measure a learning rate. So it's sort of that tension level adjustment, if you would, that monitoring cadence, just sort of changing from, if you add this, it would change from 14 days to 7 days for critical patients based on outcomes. If you add this one more productive agent, and you begin to see how that agentic workflow begins to demonstrate exactly what separates that golden top successful 5%. They're the ones who build those learning systems, as you see over here, with all the productive tensions, that rather than just trying to eliminate friction. So finally, you have to quantify all of this. You've got to use some sort of a structured disagreement forum stand-up. I gotta have daily stand-ups where, you know, your tight 3-person pod, again, first principles thinking and organizational talent density and so on, 3-person pods, they synthesize those conflicting agent recommendations. And that's how you sort of measure that learning telemetry. So you can begin to gradually increase the automation coverage, as over here, from 38% to 76%. Again, this is ultimately a toy example with simulated data. I honestly tried to build it where you could pull real world data, but public service announcement, a lot of real world healthcare data are no longer available because of budget cuts. I'm not going to go into the political situation there, but anyway, that is everything. Grant, that concludes my slides.
I love the last slide, by the way. Now go slay, everyone. But before then, we're going to ask a few questions. I have some personal questions just to kind of help the audience both recap and also for my own personal interest. So, Mash, one of my first questions is, what exactly is talent density and how do you measure it?
So talent density, that really refers to that concentration of high performing individuals
Hmm.
that you have in the team or the organization. Again, it's not about hiring smart people. You're designing the organization around them. Uh,
Hmm.
you measure uh, it sort of, you can do this by looking at output per employee, revenue per employee, or their decision-making autonomy. You can do things like, well, their ability to innovate over and above an existing process overhead, and so on. So you don't have to use revenue per employee. You use proxies, figure out what those proxies are. And that sort of helps you figure out that talent density equation that's specific for your organization. Good question.
Amazing.
Yeah.
Yeah, thank you. Very helpful. I'm sure that helps a lot of people in the audience. And another question I have for you is, what do you mean by AI leverage?
Oh, that's a really good one. Um, wow, my texts are coming from my daughter. Uh, so AI leverage is that degree to which AI amplifies the human capability. I mean, think about it. It's not just automation. It's augmentation. So it's some measure of how you use AI copilot agents. You can, and the orchestration frameworks, all of which then allow these very precise teams to begin to do the work of many people. And it's how, again, come back to same old examples like Coinbase, um, how they use AI and through AI methods to scale their compliance and customer support without a linear headcount or straight up linear headcount growth.
Amazing. So let's definitely keep that in mind about linear growth and figuring out ways that we can use AI to create that AI leverage and exponential growth. 100%. And how would you define learning velocity? Just going through the different terms that you discussed today.
Um, learning velocity is really that speed in which the organization absorbs feedback and begins to
Mhm.
improve it. Uh, all right, kids, I can see your texts. And it's measured how quickly the teams iterate. It's how fast those AI models retrain and how often the insights are shared across domains. So like at high learning velocity would be um, turns those mistakes and that could give them some momentum. That's where
Hmm.
you need to be very cautious of knowledge management isn't exactly the right word to use, but at least idiomatically, that's you want to keep some level of control on that learning velocity.
I see. Absolutely. So making sure that we have those lessons learned and everything else that you discussed here today. And why is the equation exponential?
Oh, that's because each component reinforces the others. You can't have talent density. Talent density enables the better use of AI. AI leverage accelerates the learning, and learning velocity. That just compounds the growth. So that's why it's not linear; it is exponential. And I'll jump ahead. You can't lose any one of those variables. All of them are important. That's why even in the
Hmm.
heuristic, they're all important. And so if you drop one, that just drops the whole that exponential growth equation as a common idea based on this. Put it to
Amazing.
test. Put it
Hmm.
to a test in your own organizations.
Yeah, absolutely. And I'm sure we will. And another question from the audience,
Yeah.
and in the context of what you were just discussing, is in terms of an example, could you give a real example of the equation in action?
Yeah, Netflix again. That I know. Um,
I
they
watched them a lot myself.
Yeah, well, they optimize for talent density. I mean, there's so much written about it. And even as Reed Hastings has retired, he's been doing tons of podcasts. And I I wish I had really focused on Reed Hastings in
Hmm.
years before when he was at Netflix versus just catching up to his thinking and mindset now. But he optimized Netflix for talent density, building the recommendation engine that learns from every user interaction. Um, that's AI leverage. And then they do hundreds of A/B tests daily. That sort of feeds into their learning velocity. And that's how they say. I mean, if I recall, like over $1 billion in savings from retention. And of course, I showed the 6.5 times revenue per employee compared to Disney. Unfair, but rough.
And very impressive. And speaking of all of these different variables, how do you handle when one is weaker than the other? What do you do? How do you measure that? What are your thoughts on something like that?
Yeah, just as I mentioned, like think about a minute ago, the entire equation breaks down.
Right.
You have high AI leverage, but you don't without the talent density, then you've got poor oversight. If you have high talent density, but you don't have the um, learning velocity, well, that's high talent density. You're just going to have stagnation there. You're not going to really grow. All of those variables have to be present, and they have to reinforce in order to get to that exponential growth.
Understood. And that's why measuring all of these variables is very key for our companies. And a question for myself, I'm sure for many of the audience, is how can I apply this equation in my company?
Um, So the equation is not an equation, it's a heuristic. It's not a formula that you can put into spreadsheets.
Right.
But if what you can do is you can track proxies. So like revenue per employee is a proxy for talent density. Automation, agent performance, those sorts of things you could use as proxies for AI leverage. And iteration cycles, the model refresh rates, perhaps, for learning velocity. if you have agents that sort of are built around that. So you take that heuristic, figure out the applicable measures in your company, in your business model, in what it is that your function does. And this could be human resources, this could be supply chain, this can be something in healthcare or product development. Yeah, use the proxies,
Well,
proxy measures.
amazing. Well, thank you so much, Mash. I believe that we are getting pretty close to time, and I just want to say thank you so much for sharing all of your incredible insights. I know that our community and the OpenAI Academy community learned so much from you. And so with that, we're going to go ahead and just say a last few words and say thank you, Mash, for answering the questions, as I'm sure many folks in the audience had. As always, your insights are incredibly valuable. As always, Mash is such an informative speaker, and I implore all of you to keep up with his research on this, that he will be publishing soon to a Substack. We'll be sharing the paper in our DeepStation community, which you can see in the QR code and on the slides that will be shared. In the chat, on the GitHub repo, and through the QR code, see it on the presentation deck here. We provide AI educational content for not only business professionals, but also for developers and creatives. We recently hosted William Falcon from Lightning AI, and we will soon be having our first DeepStation MoonMax AI Film Festival in partnership with Raindance Film Festival. So please join our WhatsApp to ask any more questions, Discord for our open source challenges, YouTube for more of our free educational content, Luma for our next events, and our IG for the stories, and of course, our newsletter. So thank you, everyone. And I look forward to seeing you at our next session on the OpenAI Academy with Aniket Maurya, former research engineer at Lightning AI, where we'll be teaching you how to build a multi-agent system using OpenAI Agents SDK. See you soon.